Hey everybody, how you doing? It is Friday morning, the 9th of December. 9th of December. 2016 is almost over. If you can hear me and see me, let me know. Post a message in chat. Any one of the three. We are live on YouTube and Twitch and Beam, all three of them. And yeah, how's everybody doing this morning? Y'all ready for watching me not do very good at OpenCV? Yeah, so, Amin asks, what is it about this time? Well, Amin, it is hopefully, fingers crossed. I have no other lucky charms and don't really go for suspicion. Anyway, it's supposed to be about OpenCV this week. So OpenCV is a pretty cool library that lets you do computer vision. And computer vision is like having a computer see something. And then as the computer sees something, you have the computer do stuff with what it sees, right? So it could be that you have the computer, for instance, let's look over here. For instance, this person uses OpenCV to look at playing cards and then determine like what the cards are. So have the computer look at this set of 4 cards and go, okay, that's a 3 of hearts, that's a 9 of spades, an 8 of spades, and a 7 of hearts, right? And then use that to play, I think he's playing 24 or something like that. I don't know. I've not heard of the game 24. So anyway, OpenCV is a library that would let you do something like this. So it can look at these things and then do something with them. You could also do things like this, where they take this picture and they take this picture and they extract facial bits and pieces and then combine them together into a new image. So OpenCV can do something like that. Moet, I am not doing OpenCV with Android. I'm going to be doing OpenCV with Python because that's my language. But I am switching to an Android phone soon, so perhaps I will start learning Android and playing around with that at some point, because that could be fun. Another really common OpenCV thing that a lot of you have probably played with is if you've used Snapchat, and Snapchat has its filters where it'll put, you know, like a dog face on you or a ring of flowers around your head or whatever. They're using OpenCV for that. They're using OpenCV to look at you and then to identify your facial markers, so where eyes, nose, ears, mouth, things like that are. And then once they have that, they put something onto your image, or really onto your video stream. So OpenCV can do a lot of things, and my experience with OpenCV is that I installed it this morning. So, and I've read a couple of things, but I've not actually played with it. So we will all play with this together and see what we can come up with in a couple of hours. Does that sound good? I will need you all to help me. I will need as much help as you all can possibly give me. And we'll find out if this works or not. So does that sound good? Everybody down with that? Speak now or forever hold your peace kind of thing, because we just got to see what happens. So we good? How's everybody in chat? Y'all feeling good? Y'all ready to do OpenCV? All right, so let's try this. I've got a little guide here that's actually from the OpenCV Python tutorials docs that is supposed to let me capture camera and play with the camera a little bit. So let's see if that will work. OpenCV uses NumPy for a lot of stuff, and NumPy is another one that I don't have a lot of experience with. I need to do more with NumPy. But let's find out how this works. So we're going to do video capture, and I'm going to bet I need to video capture 1. So I have 2 cameras, right? So there's this camera over here that's on my laptop, And I give you the side view because when I look at chat, I'm looking over this way, so I figure that makes more sense than the other way around. The other camera is on this monitor, and it's not used on the streams anymore. So I'm going to try to capture this one, and I bet this one's camera number 1, and that would be camera number 0. So let's find out. So then we do a while true, which it's weird that they use parentheses in that. But anyway. So we've got ret and frame. So frame is going to be the frame that it's reading because we're capturing frame by frame. And then let's do cv.cvt color. So cvt color seems to be convert color. You know what? While I'm in here, let's downloads. Let's see if we can find OpenCV. Check that out. All right, so we'll get that downloading while I'm working with this stuff in case I need to look up some things. All right, so we're going to color the frame. We're going to convert the color of the frame to cv2.color.bg R2 gray. And is this confusing to anyone else? I'm pretty sure the BGR is for RGB, but I guess they alphabetized it? I don't know. I don't get that bit, but whatever. So then we're going to do image show, which shows an image. Frame is the name of the window. And then gray is the image that we want to show in that. And then wait key 1 and 0xff is equal to ord q. So I guess if I hit Q, then we'll break. All right, and then when everything's done, we're going to do this cap.release and cv2.destroy all windows. All right, let's see if this works. Run camera. Oh, something failed. Oh, because it's not and. It's just here. That's not how you do it. You don't do and. All right, so let's run camera. I'm looking for new windows. Oh, we didn't get a window. Oh, because that is CV2, not CV. All right. Now let's try it again. Hey, check it out. Okay, so that is not camera 0. That is camera 1. So let me hit Q. Q, escape. Q. Let's just stop. There we go. Okay. I had a better one over here that was we pressed enter, or we pressed escape to make this happen. It's just wait key 0. Yeah, just wait key 0. Okay. Oh, maybe that needs the bitwise. Maybe it needs that. Okay. Let's try that. All right, so camera, we're going to run that one again. Cool. So I have my camera, and I'm in black and white now instead of in color. Y'all can see that video, right? I mean, it's on the screen. I'm assuming you can see it. And yeah, Marine, holy, it did stuff. That's amazing. Okay, and check it out. We can see here that it's dropping some frames. Like, every once in a while it misses a frame, apparently. Okay, so that's kind of cool. And the Q makes it get rid of it, so it was the bitwise and that it needed to have there. Okay, so what else can we do with this? So I can obviously change some colors here. I saw other things in here. Let's see what else is here. Color, I don't know what Bayer is. BGR to HLS. Alright, so that's just going to change color schemes. Well, if I change color schemes, can I modify the color somehow? Let's see what we can do with the converting colors. So let's just say like output equals cv2.convert color. Let's look this up. Okay, here we go. Drawing frames because the while loop is looping faster than it can feed the frames. Most likely, yeah, Marine. That's probably why it dropped the frames, is just that Python's going a little faster than OpenCV can actually update things. And that's fine. So that's cool. And yes, that is an awful lot of color schemes. RGB depth processing. Man, there's so much stuff in here. And y'all, seriously, I have no idea what I'm doing. So I'm just kind of playing with stuff, and let's just see what we come up with, because we might find something really neat. That's breaking. Yeah, it's not going to break anything having the missing frames. Oh, here we go. Let's try this. Let's try blurring me. cv2.gaussian blur. Okay, so let's try that. So I'm gonna put this one back. So what was that? RGB, no, BGR to gray. That was it. Okay, and then blur equals that, and so my source is gonna be frame. K size and sigma x I have to give. So K size is the Gaussian kernel size. So I'm guessing that's probably a tuple. And then sigma x is the standard deviation in x direction, standard deviation in y direction. Okay, let's just mess with this. Yeah, let's just see what we get. So K size, let's do 10. And sigma x, let's do 10. Okay, and then let's show blur. And I'll comment that one out because we're not going to show gray. Midden, will this be uploaded? Yeah, it will be uploaded in the channel once it's done. I think the plan is that we are going to post all of these, so we should be good. All right, so, what? Oh, yeah, this one was supposed to be a tuple. There we go. And camera? No camera. Okay. K size dot width greater than 0. K size dot width divided by 2 is equal to 1. K size dot height. Something it doesn't like. Nines. Let's try 9s. Hey, check it out. All right, I'm blurry. I'm a bad security camera. Okay. Let's try increasing that. Let's go way up. Let's do I don't know. Let's do 45. Let's do something offset from each other. So let's do 45 and 23. Wow, okay. I can kind of see that it's different on one side to the other. That's kind of neat. All right. Okay. So let's put these back to the same. Let's do this as like 5. And I want to see if I can flip the camera over. I want to turn the camera around, and I'll leave that going while it's blurred. So we can do image processing. We can do filters. That's fun. We can do dilation. Oh, let's see what dilate is. dilates an image. Okay. Rotation matrix. Drawing functions. Okay, so I could draw on my picture, which that could be fun. Motion analysis. Feature detections. Okay, we'll play with all of that in a minute. All I want to do is see if I can flip the image. Press flip. Yeah, if I was to put gray into blur, yeah, let's get bad security camera footage. We'll do this with gray. Maybe we'll make this a little smaller. Maybe we'll do like 11 by 11. All right, y'all ready? Here we go. Yeah, bad security camera footage. That's pretty good. All right. So now it just needs to be like distorted. Bring in some scan lines. That'd be fun. All right. Okay. So all I'm trying to do is I'm trying to flip the image over, right? Which that can't be that hard to do. Actually, let's just do this. Let's do OpenCV Python flip image. Right? Because it's flip flop. I don't know that it actually matters. How to flip an image. There we go. So flip, and then I'm going to put in blur, and destination array would be, wouldn't that be the same? Here we go. Let's look up flip. Okay. Flip source flip code. Flip code is a flag to specify how to flip the array. 0 means flipping around the x-axis, and positive value means flipping around the y-axis. And negative is flipping both. Okay, so I just want to flip 1. So right here we do 1. And then here we'll do flipped. And then if we run this, and I didn't typo anything, there we go. Now I'm a mirror, right? Like if I was looking at this, if I'm looking at a mirror, this is how my mirror works. Oh no, it's dropping frames when I take a drink. Okay, so we've got some basics. That's pretty good. Let's see if we can do feature detection. So I'm gonna rename this. Refactor, rename. I'm gonna call this security camera. And so that way we can hold on to security camera. Okay, so let's try doing the feature detection, right? Let's see if we can do, let's see if we can do this stuff. Oh, that's not what I'm looking for. Okay. So features 2D, feature detection. A feature detector. I don't want to see that in C. That won't do me any good. Feature detector, create image, key points. Okay. Let's see what happens with this. Let's make a new file, features.py, and let's go back over here to security camera and take a bunch of this stuff out, as in all of it, just so that we have the frames and stuff like that. Okay. So then let's look at this thing. So we've got cv2.featureDetectorCreate.detect, and then we pass it an image. And that's going to give me back this thing called key points. Okay, so I just want to see what's in key points for now. Key points equals cv2.feature detector create dot detect frame print key points. And we can just show frame. Actually, we don't even need to show frame. But whatever, that's fine. CV2 has no attribute feature detector create. Does it not? Okay. I guess it doesn't. Now, this could also be some things that I just don't have installed because I installed a fairly basic one, so I don't know that I got everything. Prominent corners of the image with specified image region. Calculates corner quality measure. Let's see what we can do. Let's just look at tutorials and see what we can figure out. Sweet. So we got something here from Real Python. They've been handy before. We've used them. So let's give this a try. So import cv2, import sys, cascade path. Okay, so they're making an image cascade. Okay. That might not have been the best idea there, dude. Showing off your license. Okay, so what are they doing with this? Face cascade, cascade classifier to there. Okay, so what I'm going to do is, instead of that, I'm going to import OS, and I'm just going to have it saved to this directory. So I'll do cascpath equals os.path.join. What is it? os.path. There's a thing for getting the current environment. Get CWD, that's it. There we go. So we can just go to there, and then face cascade, cv2.cascade, classifier, cascpath. That needs an individual file name. So let's do os.path.join. That plus, I don't know, cascade. Hey, Blue Gaming TV. Welcome to the stream again. And you think you're going to start learning C++? Go for it. I mean, it's a good, solid language. We wouldn't have most of the things that we have now without C and C++. So, yeah, go for it. while true, ret frame equals video capture dot read. I feel like we've done this part before. I want to know about this video capture. Oh, I need to go over there. Is there a way that I can... I wonder if there's a way that I can have this read, like, slowly. Maybe not. Okay, whatever. That's fine. Okay, so ret and frame cv2 dot... Have you noticed everybody does the... Everybody does this grayscale thing. So that's kind of interesting. I mean, it's fine. It makes sense. It's just interesting. Min neighbors is 5. Min size is 30 by 30. Flags equals cv2.cv.cv har scale image. Okay. I'm wondering if that one actually exists. For x, y, w, h in faces, cv2.rectangle frame x and y, x plus w, y plus h, 0, 255, 0, 2. All right. Okay. Okay, cool. cv2.im show video frame. If cv2.wait key 1 and 0xff is equal to ord q, then break. And then when everything's done, video capture.release and cv2.destroy all windows. Which sounds like somebody who really hates Microsoft, but yeah. All right, let's see if this works at all. Let's find out. No, did not work. Okay, so we don't have this flag thing here. So that's cool. Let's check out this detect multiscale. Okay, so flags. Parameter with the same meaning for an old cascade as in the function cv har detect objects. It's not used for a new cascade. So flags is optional. Let's leave off the flags and just see what happens. Oh, something failed. Something came in as empty in that one. Okay. So let's check if we have this Haar scale image. No, it doesn't look like it. Okay. Detect multiscale. Detect multiscale 2 and detect multiscale 3. They all work the same way. And it could be just that I don't have a certain, like, some certain things installed. So, we may have to find some other stuff here. And that's fine. We may have to try something different. OpenCV 1x API only. Okay, and I don't have Open... I don't have OpenCV 1, I have OpenCV 3. So, or rather, I have, I guess, what they're considering to be OpenCV 2. But we don't have this thing. Okay. Golson, this thing that I'm using right here is called Dash. And Dash is pretty cool. Why did I hit that key? That's not a key I need to hit. Okay, so let's look here. Let's do OpenCV. No, not an available package? Okay. That's cool. Let's try this then. Which Python version? That's not what I wanted. PyEnv local. There we go. Okay. So I should be able to do. How did I do this before? Let's just look for OpenCV. There's OpenCV 2. This seems like a bad idea, right? Yeah, it seems like a bad idea to go and be like, I should install other versions of OpenCV. So I'm not going to do that. So let's try OpenCV 3 Python facial detection and see what we find. Also, I know I have some stuff here, playing video from a file, saving a video. That's not what I'm looking for. Let's look at feature detection. Feature matching. That's not quite the same thing. Video analysis. Optical flow background subtraction. That's kind of fun. Yeah, Mallory, it might be Python 2. I'm not sure. I don't really want to deal with Python 2. Here we go. Let's see what this one says. Okay. So it's got all that stuff. And so they've got these 2 cascade classifiers. Okay. So let's see if I can find these files. These XML files are stored in OpenCV data Haar cascades folder. Is that under this place? OpenCV create samples. That's OBS. That's not my terminal. OpenCV create samples. Is that a thing I can do? Hey, it is! Check that out. Okay, so then I give it some sort of name? OpenCV. No? Okay. Haar training, is that a thing? No, it's not. Okay. But OpenCV create samples is. But it looks like that just creates scam. Oh, there we go. Wait, dash info OpenCV Haar training. That didn't do anything. That did not do what I wanted. How do we get this to work? Okay. Give me all that stuff. But you're not telling me what to use here. Oh, I have to already have the set of images. That's not what I was looking for. Alright. So, here's my idea. Let's try going over here. And let's try going to GitHub. Edit on GitHub. There it is. Shad, do you have to have a Mac? Do you have to have a Mac for what? Data. Oh, those aren't the things I was looking for. Feature matching, background subtraction. Okay, where did that say? They listed OpenCV data Haar cascades. For official tutorials. Okay. That's not found. Cool. That helps. Let's try GitHub OpenCV. So all I'm trying to do right now is I'm trying to find these data files that we can use for the training. So there's data. Hey, there's the Haar, the cascades. Okay, cool. So let's just download the zip of this. And that's going to take a little bit. And then I'm going to get these cascades in, and we will we'll load them in. So, yeah. And yeah, OpenCV can be installed on literally any system. Some are easier than others. Others are harder than others. Ken Alger asked in the Beam chat which version of OpenCV do I have. As far as I know, I don't think I can do this, can I? No. As far as I know, I have the latest. It's like OpenCV 3 point something, like 11 something. And Chad, you can code on literally anything. You can do programming anywhere you want to do programming. OpenCV master data. Okay, so let me hop over here to Pytron projects CV live stream. All right, and then I'm gonna go into here, into here, into here, into here. Yeah, let's just grab all of those. So star.xml to here. Boom. All right, we got a bunch of XML files. So now, let's try doing this stuff. And I'm going to get rid of all of that, and I'm going to follow this official tutorial, because that makes more sense. Okay, so numpy as np, which I don't know if we're going to use that, but we'll find out. cv2 face cascade is equal to cv2.cascade classifier Haar cascade frontal. I'm not going to do cat face. I don't believe I have a cat face. Face default.xml. Alright, and then we'll do I cascade cv2.cascade classifier Haar cascade I.xml. Alright, yeah. And then image will be cv2. And I don't actually want to do this with image read. I want to do this with a camera. So let's grab this stuff. And we've got cap. Okay, so there's our image, and there's our converted to gray. Gray. That was fun. Okay, so now let's do faces equals face cascade dot detect multiscale. We'll do this against gray, and then 1.3 and 5. Let's see what those are about. So we've got the image, and then we've got the scale factor, which is specifying how much of the image size is reduced at each image scale. Okay. And then we've got min neighbors, which is how many neighbors each candidate rectangle should have to retain it. I'm guessing that's like the size of the match. Like I said, this isn't a thing that I know a lot about, so I'm kind of just guessing here. We'll find out. Okay, so that's our faces. And then we'll do for X, Y, W, and H in faces. Image equals cv2.rectangle of frame. Yeah? Or no, yeah, frame. Yeah, frame. Yeah. And then X and Y. And then X plus W and Y plus H. And then 255, 0, 0, and 2. So that is, what are they doing there? 255, that'd be red? Or no, I guess that might be blue for them. So that's the blue for the face. And then ROI gray is gray Y to Y plus H, X to X plus W. And ROI color is frame, Y to Y plus H, X to X plus W. Eyes equals eye cascade dot detect multiscale. ROI gray for EX, EY, so IX, IY, eye width, and eye height in eyes. CV2.rectangle. So this is when we're drawing rectangles on stuff. ROI color, EX and EY to EX plus EW, EY plus EH. Those are hard to type. 0, 255, 0, 2. Okay. So then we're showing the frame, and we want to just show frame, right? Yeah, so this should be frame, not image, because we're overwriting the frame. And then let's just call this video, and then we can do all of that. All right. What do you all think? Do you think it'll work? Oh wow, check it out. It's kind of sort of finding my eyes. It's not doing an amazing job, but it kind of finds it, and it's definitely dropping frames. Like you can definitely see how choppy it is. Let's try just grabbing a random thing over here. Let's see. Is there a face on that? There's a face on this. So does it find that face? No. No faces? Okay. Maybe that's too abstract. Sorry, I'm looking for things with faces on them. And most of what I have is just board games, which may or may not have faces. That one doesn't have a face. That one doesn't have a face. Why doesn't anybody make a board game box that's just a giant face on it? Okay, this one has multiple faces. Ignore how bad this art is, please. This art's horrible. Yeah, we cut a face in there. Sweet. So we can find faces and eyes. All right. So, let's see what else we can make this do. Gossam, this is not plagiarism. I mean, I'm literally copying an official tutorial. So, yeah, but it's not plagiarism, right? It's not the same idea. And if you really want to check that and you want to call plagiarism, then if this is the exact same, looks like ScentDeck must have copied these people, huh? Yeah. Right. So yeah, it did. It found the goat that's over there. That's the Python testing goat. So so that's cool. It found the goat. So let's see if we can go a step further. Like we found the eyes and we found that stuff. So what we would do at that point probably is try to put something onto the camera, onto the video, right? So I have no idea what I'm doing on this part. Let's find out if we can. First of all, let me see if I can clean this up a little bit. See if I can do a directory and I can do like data. And then if I take all of these and move them into data, that's fine. You gonna do it, PyCharm? Okay, we gotta give PyCharm a minute. And yes, Mallory, you should obey the testing goat. Yes, obey that goat. Wow, thanks, PyCharm, for just freaking out there. Cool. Oh, did it do it? It did it. Sweet. Okay, so there's that. So now I should be able to put data in front of here. And then I should be able to run it again. And it should spot me and the goat. I think it's funny that it finds the goat's horn. It thinks the horns are eyes. That's pretty good. Okay, cool. So let's get over here and hit Q. All right, so that works off of a single image, or it works off of a video, rather. And, oh, wow, that's an amazing goat. Pause. That's the one bad thing about doing most of this on YouTube is YouTube doesn't have, like, custom emojis or anything. It would be awesome, or custom emotes. So it'd be awesome if it was mostly on Twitch or Beam to where, it was, you know, we had custom emotes and stuff like that. But, whatever. And yeah, Mallory, I'm sure it is actually reading all those XML files, just trying to make sure that they are not referencing each other, and it's looking to see where they are referenced. But, you know, whatever. That's fine. Okay, so if I can find the eyes, then I should be able to put something on the eyes, right? Because there's stuff here about, like, compositing, right? Computational photography. Do you have an old degraded photo with many black spots strokes in it? No, not that one. Video analysis? No. Image processing. Smoothing. Lots of smoothing there. No, I just want to put a new image on top of another image. Algorithmic operations. Camera calibration. Depth map, so that's handy. Machine learning. Those aren't what I'm looking for. Computational photography is not what I'm looking for. Facial detection, we figured that one out. OpenCV bindings. GUI features. Drawing functions. Let's try that. Let's try, I know that I drew that stuff, but maybe there's something on here for... Oh, there we go. Image edition. So, can I stick another image on top of... So when you add two images, image blending, that's me blend two images. Okay, bitwise operations that you put. So we have an image mask, and then we have a final result. Okay, so that one's probably pretty close to what I'm looking for. Yeah, that's going to be close to what I'm looking for. But I want to see if we can do, like, let's just try searching for, say, sunglasses cutout. Yeah. There's one. That's probably not really free for use, though. Usage rights, labeled for reuse with modification. Yeah, that's cool. Let's make sure safe search is on, just in case. Oh, mustache. I could do a mustache. That might not do a whole lot for me, but I could do a mustache. You know what? Instead, let's actually do this. Let's go back here. Let's grab this image. Save image to downloads. The age-old trick of tracing images. Alright, we can close these, so we're not making a game today. Did y'all enjoy the streams where we made games? Because I thought those were pretty fun. Hopefully we will get to do some more games at some point. Downloads. Where are they? There they are. Unsplash. Yeah, Unsplash does have some cool pictures. But this one, I think I can quickly convert this to what I'm looking for without having to do anything special. No constraints. Because literally all I want to do is get the shape of these. I don't even care about the color. So I think this will be just as easy. Delete, deselect that. Image, trim, transparent pixels. And now everything that is not a transparent pixel edit, invert selection. There we go. That is good enough for my purposes at the moment. Except I don't need these little tail things on the sunglasses, because those just look funny. Alright, and now let's trim it again. No? Okay. There we go. Close enough. And let's export as a ping. Actually, I mean, JPEG will be fine too, but let's do it as a ping. And this needs to go to PyCharm projects, CV livestream, and I'm going to call these glasses.png. Okay. Now let's see if we can do this. Adding text to images. That's not what I want. Adding and modifying pixel values. image ROI, certain regions of image for eye detection, face detection until the face is found, the search within the face. Yeah, okay, that makes sense. Making borders for images. Padding. Okay. Arithmetic operations. Okay, so let's see if I can just get the glasses splashed onto my my face, or just my stream period. So let's say glasses is equal to cv2.imageRead glasses.ping. Okay, and so that's it. So then, okay. I'm just having to watch and look here wherever they're doing image 2. So then they make that, which I'm not going to worry about that for now. Let's see, what is this doing? Rows, calls, channels equals glasses.read, or no, .shape. Okay, and then the region is going to be, see this down here, region is equal to frame 0:rows 0:calls. Okay. Okay, I see what they're doing there. And then they're blacking out that area. And then they're getting the foreground from that one. Okay. So ret2 mask cv2.threshold. And the source here is going to be, yeah, and we could do gray glasses is cv2.convertColor of glasses to cv2.color bg. Yep. All right. So that gives me gray glasses. So then threshold here is going to be on the gray glasses. And 10.255 cv.thresh cv2.thresh binary. So threshold's binary. It's either on or it's off, right? Okay. So then what I want to do here, and this is just to put it on. I want to do frame equals cv2 dot add. I don't want to black out that area, so I'm just doing frame. And then sorry, y'all, just trying to figure out what I'm doing here. So bitwise and glasses. That shouldn't be max, that should be mask. And then mask equals mask. Okay, and then here I would add new glasses. Let's see if that works. All I'm looking for is that glasses show up. No, that didn't work. Okay. Okay, where did I fail? I failed on this one here. And on this one, they have the bitwise and, but I don't want that bitwise and. I don't want to do that. I just want... All right, you know what? Let's just try it. Let's just, the worst thing that happens is it fails, right? So frame 2 is cv2.bitwise and of ROI. ROI, and the mask is equal to mask inverse, which, where was mask? Here was mask. So mask inv is equal to cp2.bitwise not of mask. So we're just swapping that around. Mask inv. Okay. And then this would be frame 2. And then I would say frame 0:rows 0:calls equals DST. All right. Hey, there it is. Okay. So can you see? It's super faint, but there is an outline right here of the glasses. Y'all see that? Okay. Cool. So something showed up. Not necessarily what I wanted, but something showed up. Okay. So now the glasses already are. Let's go look on Unsplash. And see if Unsplash has like some glasses. Like, I love Unsplash, but they are mostly like those kinds of shots, and not things I can easily use as like they're mostly like stock photo, right? And I'm kind of looking for something that I can easily stick onto my face. I can stick a... yeah. Oh, wow, that looks like our old office. Those light bulbs are horrible. Don't ever use those light bulbs. I know the Edison bulbs look cool. Just stay away from them. Trust me. Trust me, y'all. All right, I'm not going to worry about that one. What I'm going to do is... oh, that's not what I wanted to do. Downloads. This one. There we go. Okay. So now I will take... that not do? No, that didn't. Okay. That did pretty well on matching those up. Okay. Okay. Deselect. Let's get rid of that. Let's export this one. And you know what? JPEG is fine. Okay. And let's go over here to this live stream. And this one's actually going to be glasses.jpg. And then this one I will export. I don't know if I need to do this or not, but let's find out. As glasses mask.jpg. Okay. So let's see what happens if we just use this with glasses.jpg. To see how it does with the mask, right? Hey, there's that. Okay. It's sadly not transparent, but there's glasses. I have glasses. Okay. So, cool. Let's quit. Hidden Q. Okay. That was a lot of Qs. Okay. So, okay, and you know what? I can do this stuff up here. It doesn't need to be done inside the while true. Inside the while true, I just need to do this stuff. Okay. So let's see if we can get the glasses masked in with just the mask. I wish I could like print out the mask. But I wonder if here I could do imread glasses mask.jpg, and it's imread, not imgread. Okay, let's see what that does. No, that died. Okay. Why did that die? Because it doesn't like something there? Doesn't like something that I did there. What did I do that it didn't like? Okay, so let's see. So here they've loaded up the picture of Messi. And then here they've loaded up the OpenCV logo. So then they get the size of the OpenCV logo. And then the ROI is on image 1, which in our case is the frame. And they make out an area that's the size of the OpenCV logo. Right? Yeah. So then they make a mask of the logo by doing this convert color, and then they make, or rather they make the gray image, then they make a mask by calling threshold on the gray image, which I did. Okay. And then they do a bitwise not on that to invert the mask. So then they want to black out the area. So ROI, ROI, and mask is set to inverse mask. So let's look up this bitwise and. So source 1, source 2, and then a mask argument. Okay. 8-bit single-channel array that specifies elements of the output array to be changed. Okay. So we take the glasses and the glasses, and we set the mask equal to the mask that we made on there by calling threshold on that converted image. Did that not do it? what if I do gray glasses equals CV2 dot convert color gray glasses to CV2 dot color BGR2 gray. Okay, we got them. But I don't actually want to invert that mask. I think I want to do it with the actual mask. Because my mask is, yeah, I'm not smart there. Okay, that's closer to what we want. Okay, so now what I need to do there, mask, would this be inv? Check it out! We got green glasses. That's awesome. Okay. There's the green sunglasses. Okay, that's great. So one thing I do need to do on this is I need to get rid of right here inside there. You shouldn't be able to see anything because that's going to look weird when this is scaled down and put onto my face, which is my goal for the next hour. So let's see if we can make that happen. So there has to be a way to scale images down, right? Read an image, display an image. I have to be able to scale an image. Matplotlib. Basic operations on images. Splitting and merging channel, accessing image properties. Accessing and modifying pixel values. Drawing functions. Okay. OpenCV3 Python resize image. Geometric image transformations. Resize. Convert maps. Resize. Remap. Resize. Resize is an image. Who would have thought? Okay. Destination size. Right? Desize. Okay, so now I need to be able to get the distance from the left eye to the right eye. So I need to get the distance across that. So first, let me hop back over here to Pixelmator. Let me fix that inside bit. There we go. Okay, so turn that one off. Turn that one on. And I can make this less confusing by inverting my mask there. Maybe I'll do that in a minute. But what I want to do is I want to grab... that's way more sensitive than I wanted. Yeah, okay, you're not doing what I want. What about you? Will you do what I want? Oh. Silly me. Okay. Haha. Thank you. And then over here, let's just get all of that and fill that with black. Okay. And then this image, color adjustments, invert. I mean, that sort of did what I wanted. Yep, all of that. Fill with black. Okay. So export JPEG. And that was glasses mask. Yep, replace that. And then export JPEG Glasses. Okay, so I'm pretty sure that at this point we're going to have to invert that mask again. Yeah, got to invert the mask. Okay. So where was that? That was here. Let's make sure these are showing up correctly again. Nope. That didn't do what I wanted. This one. There we go. Okay. All right. Cool. Okay, so now let's see if we can find the distance from the one eye side to the other eye side. Right? So I've got this eyes thing. Let's print out eyes. And just see what it says. Okay, so if I'm looking at eyes, I've got like right here, we can see 69, 90, 45, 45, 42, 42. Occasionally we get a whole lot of them. Let's do this with a still image. Let me find. All right, now y'all don't judge me on this, okay? Because I'm about to show you something that maybe a lot of y'all don't have, but I have it due to work, which is just a lot of pictures of me. So just no judging on the fact that I have a bunch of pictures of me in a handy dandy folder where I can just go grab things. So I'm trying to find one that has a face fairly straight on. That'll work. Okay. So let's open that with Pixelmator. Yeah, it's just weird having. I also have GIFs of myself. Like, who has GIFs of themselves? So here we go. We will cut this out right about there. Good enough. And export that as face. All right. Close that. Delete. Quit Pixelmator. Okay. So now I'm going to go back to the tutorial that I had. Yeah, like here. And I'm gonna take out all the camera bits because that's just not helping. And I'll get rid of that as well. So, which means I don't need. Here's a really quick way to comment stuff out in Python. So there we go. If you find yourself going, wow, I really need a way to do stuff in Python, this is the way to do it. Okay, so then let's do face equals cv2.imread face.jpg. imread. Okay, and then I want to come back down here, grab this stuff. Grab this stuff. Paste it in right here. And then here we would do cv2.destroy all windows. Hey Ryan, welcome to the stream. Actually, we can take that out, and we can just do cv2.wait key 0, and then the destroy all windows. And that will show that. Okay. So, to get back to what I was doing before, this would be face, face, face 2, face 2, face, face. Alright, and face. And face. Okay, I don't know if this is going to work, but let's find out. Yeah, Mallory, you can do the command /, but for some reason in mine, probably due to my Vim keys, it does not like command /. So, check it out. Well, we found sort of an eye. We found an eye, a very sad eye, a very tired eye. But we found a face, and we found an eye, and we got glasses into it. So that's a good first step. So now we'll figure out the next one. Rezwong, can you suggest a book for JavaScript? You know, I don't do a lot of JavaScript, so I don't necessarily have a book that comes to mind. I've heard really good things about, oh, what was it? Chalkers was talking about one recently. JavaScript, the good parts, of course, is supposed to be pretty good. But there's another one. If Hemingway wrote JavaScript, I think that one's supposed to be really good. But yeah, I don't... Hold on, I have a couple that I bought in a bundle recently. Eloquent JavaScript, I think, is supposed to be pretty good. And then If Hemingway wrote JavaScript. And I've been a pretty big fan of the 4 Kids series that No Starch Press does. So you might check out their JavaScript for Kids. Usually they teach whatever language they're teaching through video games, which is always a fun way to learn stuff. Okay, so we found faces. We found one eye, and it wasn't actually an eye. So I might have to try a different image. But what I want to try to do is I want to try to find... so we've got eye and we've got width. So if we can take X and W from each of those, and we take the X from the first one, we take the min X, and then we take the max X plus max X W. All right. Min X is 0. Max X is 0. Max W equals 0. Okay. This is not an optimal way of doing this, but we'll just find out. So if X is greater than, or no, is less than... Okay, that's on eyes right there. So then we're looking through each set of eyes. Okay. So min. Sorry, this needs to be... what does shape get me? Nope, not that. I am read. So I am read gets a thing, right? It gets me an image there. So let's do this. Let's do face shape equals face dot shape. No, there's what I want. Rows column. Okay. So min X equals face dot shape. Rows would be the first one. So I want rows. and max x would be 0. Max w would be 0. Yeah. So then, min x here is going to be the minimum between ex and min x. So that will scoot it to the left as things get smaller. Max x is equal to the max between ex plus EW and max x, and I don't need max W. Yeah. Okay. So then, let's come over here and let's print min x and max x and see what happens. I think this will give me what I'm looking for. Alright, so there's that very unflattering image of me. And I got 434 and 479. So that's the edges, the ends of the glasses, right? So if I subtracted those from each other, I would get the width of the width of the glasses. Okay. Okay, I think I got it. Let me try to find a better image of myself, which that sounds really bad. But let me see if I can find an image of myself that would look better. That maybe would work better for the detection thing. Can we get this as icons? There we go. Icons. That's not gonna work. Let's try that one. Copy PyCon1. And we'll go over here to the live stream. That's not right. Pycharm projects, CV live stream. There we go. Paste that in. And what is that? That is a JPEG. Alright, so let's try that one instead. Let's try pycon1.jpg. Let's try running that. Hey, it found 2 eyes. Okay, cool. And I got 187, which is probably about right there. And we got 787 over there. Okay. So, that means I should be able to do this. Glasses width equals max x minus min x. Print glasses width. And we don't actually need to see the image. It can go away. 600. All right. So then I need to get a center y, right? So let's do the same thing here. And we'll say min y is equal to face.shape1. And max y is equal to 0. And then here we do min y is the min of ey and min y. And the max y is the max of ey plus eh and max y. And then what I want is I don't care where those are. The top I need to know. I need to know the max or the min y. Yeah, the farthest up. But I need to know like the center point, because I'll just put the glasses on the center point. Does that make sense? I think that makes sense. So let's try glasses center equals max y? No. Yeah. Max y minus min y divided by 2. And this needs to be done first. And let's see if this looks approximately correct. Quit that. 156. Okay, yeah. So let's integer that. Okay, so now we have the glasses in the right spot. So now what I want to try to do is I want to stick the glasses onto the face wherever the eyes are at an appropriate size. Okay, let's see if we can do that. First of all, let's see if we can resize the glasses to be the right size. So I have those, and let's do this here. Let's just say, I mean, really this needs to be done for each set of faces. So I'll do it in here. No? You don't know to indent that? Okay. That's cool. Okay, so I've got my glasses, I've got my width, I've got my center. So now what I need to do is I need to now do the compositing of the image, right? So like face2 is equal to cv2.bitwise and of the region, and the mask is equal to the mask inv. But the region has now changed. So the region, the ROI is going to be equal to face, and we want to start at the min x, and we want to go to the max x, and we want to start at the min y and go to the max y. Right? Yeah. Okay. So then, yeah, let's just indent that. And that won't be 0:rows. That will be... Yeah, that'll still be the min x and the max x and the min y and the max y. Because we want to override those bits and pieces. Oh, nope, that didn't work. Oh. I put in a comma where I should have put in a colon. Something it doesn't like. What did it not like? Is the problem that I made the mask out here? Is it because I made the mask? Yeah, that's probably what it is. So I probably need to actually do all of this stuff down inside here, so that I can resize the glasses to be the appropriate size for the thing. Right? Yeah, that's what we're going to say. Okay, so I'm going to do glasses equals cv2.resize glasses, and I want that to be glasses width, and then I want to do gray glasses equals cv2.resize gray glasses width. And I don't believe I'm using... Am I using rows anywhere? There. But that does no good. I don't need that anymore. Okay, so I don't use those anywhere. Okay, so let's try this. No! Oh, resize. Yeah. Okay, well, let's resize them to the height, too. So, glasses height equals max y minus min y, which means that here I can just do glasses height. And this would be glasses width, glasses height. And this would be glasses width, glasses height as well. Ah! What's wrong here? Is my mask not the right size? I don't get how my mask could be wrong, because my mask is being made from gray glasses, which is being overwritten. Right? Let's do, cv2 dot... What is the thing to show an image? I am show. Glasses, and let's do that again here with gray glasses. Let's see if that'll actually show up. I don't think it will. Yeah, because that's the part of the file. Okay, so comment out that, comment out that, comment out that. Let's just comment out all of that stuff. Okay, so there's our video frame. There's our glasses, our gray glasses. We didn't get a real glasses, a regular glasses anywhere. Oh, is it because I have the same name here? Video, gray glasses, regular glasses. All right, so they're showing, and yeah, I know they're stretched. They look horrible, but that's okay. We can worry about resizing the same direction, you know, later, or we can worry about resizing scaling. That's it. We can finish scaling in a minute. So let's see if we can figure out why these are not working. So delete that, delete that. Okay. So glasses, gray glasses. Okay, so then we've got our mask, and we're doing the CV threshold 2 of gray glasses. 10, 255. Okay, and then we're inverting the mask. And then new glasses is this one, which is being masked out. And then we get our ROI, which is our region of influence, something like that. And then we're doing our ROI here with our inverted mask. cv2.add. Why is it complaining on that? That's so weird. Let's see. What if it's... Let's try just making this one. And just see what it does. And I'm actually gonna... Yeah, whatever. It can keep showing the image. Does that fail? No, that doesn't fail. Okay, so that line's fine. What about this line? Nope, that line's fine. Okay, what about this line? That line's fine. Okay, this one should be okay, because that's just setting some variables. That one fails. Okay, so something's wrong with the with this bitwise and. Insertion failed. M type. Mask same size in binary op. Is the mask not the same size? Yeah, I mean, the masks... It should be making the masks into... It should be making the masks from the converted images, right? Like, how else would it be doing that? Threshold. Threshold. You gotta spell that correctly. Threshold. Input array, so that's one of the images. Destination would be the where it goes out to. Thresh is the threshold value. Max val is the maximum value. So source, we don't do a destination for Python because we just assign it back to a thing. Threshold value, maximum value, so 255, and then the thresholding type. Okay. So what? So what is this thing doing? It looks like it's complaining that the mask isn't the same size. Okay, they're both 312. Glasses is 312. $600. Well, now that doesn't make sense. So that one there is putting DST, which is where we're taking image 1 inverted, image 2 not inverted, putting those together and putting that into there. I don't think that's right, but let's try. Yeah, that doesn't make any sense. Okay. Oh, that's not what I wanted to do. So what if on here we did that, and then we did ROI equals face 0 colon rows 0 colon calls? No, wait. I'm getting lost. Ha! Hi. So, yeah, I'm getting lost on this. Okay, so the problem is here in the face 2 with doing the bitwise and, right? So we have ROI, which ROI, if we look at the bitwise and, we have source 1 and source 2. So these are input arrays or scalars, whatever, that are the destinations, right? The XY for the pixels for where stuff is going to go. So min X, min Y, max Y should be working. But it's sounding like, or it's looking like, the mask INV isn't doing the same thing. Let's print Roy. And this is going to fail. Okay. So when we look at this, we're getting are those color values? Okay, I'm not sure what those are. The mask is optional. Let's leave off the mask. And just see what happens. Absolutely nothing happened. That's what happens. Alright? Yeah, nothing happened. Okay. So... oh, that's because I didn't do this stuff. Ha! Let's do those bits again. And yeah, so that failed too. Array op array, where arrays have the same size and the same number of channels, or array op scalar, nor that in function algorithm op. So it doesn't like that without the mask. Yeah, that's not going to work either. Okay, so DST is the add between the background and the foreground. Okay, so I've been looking at this a little wrong. Right, that's that. So then they're adding just the logo with the mask stripped out. So I should be able to make the cameras with just the mask stripped out. And that is FG2, which they're doing the bitwise and of logo, and mask. So I should be able to do... yeah, that's new glasses. Okay. So that's new glasses. So then, after new glasses, I should be able to do like dst equals cv2.add. And that would be then face and new glasses. And then I should be able to do face 0:rows 0:calls, which I don't think this is going to be right, but we'll find out in a second, is dst. And then this can all get commented out. No! What does it not like? What does it not like? it needs this inverted bitwise and. Yeah, Mallory, I do. If you search for OpenCV 3, Mac OS Sierra, and Miniconda, you'll find one. I can send you the link in Slack later. Okay, this is what I have to do. I have to get that part working. I don't know about y'all, but I'm lost on that part. So let's find out how to get that part working. So what we should be able to do here is we should be able to do like face 2 is cv2.bitwise and then this would have this region. Okay. It has to be those, right? Let's just try something simpler. So rows and columns is that. So let's say that face min x to max x and min y to max y is equal to new glasses 0 : rows 0 : calls. Oh! Oh wait, that's this line. Okay. Yeah, we knew this line was going to fail. Okay. Comment that out. Could not broadcast input array from shape 312 600 3 onto shape 600 312 3. No? Why couldn't you do that? Why couldn't you do this inverted thing? Huh? Those should match, right? Min x, max x, that should be the width of the face. Let's see if we can draw this rectangle. Let's bring this rectangle in. Let's completely ignore glasses for a minute. Let's make sure we're even looking at the right place, right? Let's just make sure we're at the right place. So this ROI color. Okay. I think I got these. I think I got this figured out. Okay. Gray. Do we have gray? We do. We have gray. So gray is converting our face to black and white. Okay. So we've got gray, and instead of frame, we're going to do face. But instead of y : y plus h, we're going to do min. Oh, those are backwards. min y to max y, and min x to max x. Okay, I think we got this, but let's make sure. So min y to max y, and min x to max x, and yeah, that should be an x. Okay, so then we're gonna draw a rectangle on ROI color that is going from min x and min y to max x and max y. And yeah, that's fine. Okay. Sweet. Okay, and we can see here we've got at least a little bit of a rectangle right there, right? So, cool. I'm going to get rid of these other things where it's drawing rectangles. Yeah. Okay. So now, okay, we've got a little bit of a rectangle. It's kind of sort of doing what I'm looking for. Kind of, sort of, maybe, right? Okay. So now, if I swap these around, so that's a Y, that's a Y, that's an X, that's an X. Almost. Almost what I was looking for. We're very close. Okay. Alright. So, that's not quite what I wanted. Maybe it's, maybe it's like postscript and this is 0 and it goes up that way? No. That did not work. Okay. Okay. So we're back to that. So that works. And we're out of time, actually. It's 12 o'clock now. So I'll tell you what, we'll leave it here. And we'll see what we can figure out. Maybe we'll do another stream on this next week if you are all interested in that. Just let me know. We'll put up a poll on Twitter like we do every week. But yeah, so let's do a few minutes of questions. If y'all have got if you've got questions. And in fact, Damien asks why doing this live. And you said that making a mistake is annoying because you can't edit it, right? I don't mind making mistakes, which is why I'm doing this live. Programmers make mistakes all the time, right? Like we constantly misjudge things, we constantly write bad code, we constantly don't understand a thing. And so my whole point in doing this is to show that programmers aren't perfect, even though I've been a professional programmer for going on 15 years, maybe more even. I've been writing code for money. I teach people to program all day, every day for my job. I give conference talks and I'm writing a book and doing all this stuff. And so I'm supposed to be perfect, right? Like I should write great code, perfect, wonderful code, right? But I don't, because I'm human and I write horrible code and I make tons of mistakes and I don't understand things. So the whole point of doing these live streams is to show that that's what happens. That's how people actually, are. Like, we constantly make mistakes as programmers. And hopefully to show all of you that it's not scary or bad to make a mistake. And it's not the end of the world to not know something. If you were here at the beginning of the stream, I said that I installed OpenCV this morning, and that was it. That was where I started. I installed OpenCV this morning. And then for 2 hours, y'all helped me out and watched me type things in and randomly get pictures to show up or not show up and boxes to be drawn on video. And we made a really ugly security camera, right? We made this amazing thing where it's a badly out of focus and grayscale security camera. So, that's the whole point, is to just build things that maybe it works, maybe it doesn't. We're just experimenting. So, yeah. Any other questions? Or did that not answer the question? Because if that wasn't enough, let me know. And yeah, a cax. Sorry if I mispronounced that. The whole point is, to help show the process with debugging too. So you get to see the things that I do to try to figure out something. And lots of times I'm completely wrong on figuring something out. I don't know how well I did on that features thing. I think I did really badly. Rezwan asks, what's the best programming language to start with for programming? That kind of depends on what you like to do. If you really love the web and you really want to build websites and things like that, JavaScript is probably the best language for starting to program with. But JavaScript has a lot of little quirks and weird issues that you have to come to grips with and you have to understand before you can really master the language. There are languages that have fewer of these quirks and weirdnesses. Usually it's because they've been around longer or they've had stronger designs from the beginning. Python is really good for that. Java is really good for that. C and C++ are pretty good for that. C# seems to be really good. I don't know that I'd recommend starting with C or C++ as a first language, simply because there's a lot to understand in the background of those. Like, you have to understand how garbage collection works and pointers and all that kind of stuff. So I'd probably say start with like C# or Python or maybe Swift. Those are really good ones, especially if you want to build something more serious. C# is mainly going to be on Windows. You can't do Swift there at all, as far as I know. Swift is going to be mostly Mac OS. You can't do Swift on Windows or Linux, as far as I know. I could be wrong on that. So, yeah. Python's everywhere. Python's good. I like Python. Chinchana asks, is IdeaVim good enough? And do I feel annoyed by some of its missing features? IdeaVim is okay. It's not amazing. It's pretty good Vim emulation. It gets in the way of PyCharm things every once in a while, like the command / to comment things. I gotta figure out how to get that working again because it broke somewhere. I'd much rather have that do the IDE feature of commenting than have it do whatever Vim feature it thinks it's doing. And having to explicitly turn on the surround plugin is kind of annoying. But other than that, I haven't found anything that IdeaVim is missing that just really bothers me. That said, I don't use PyCharm all day, every day, so there's probably some things I just haven't noticed yet. So, yeah. Mallory says that Swift has a Linux compiler. Yeah, I think I remember it having a Linux compiler. I don't know what all Apple has deprecated or whatever as they, bring this language into their ecosystem. So yeah, you can probably do it on Swift, as well as doing it on Mac OS, which means that through the Ubuntu subsystem thing on Windows 10, you could probably do Swift on Windows 10. At that point, it feels like you're just really, really shoving round pegs through square holes, or square pegs through round holes, whichever one doesn't fit. I forget. Yeah. So you can start with any language. It really doesn't matter. Any programming language is a good language to start with, so long as it's a language that you enjoy and that you can solve problems with, right? One of my absolute favorite programming languages, let me see if I can find it, is PA or Piet. I think it's PA. And it's based on, you've probably all seen these like paintings from Pierre Mondrian, which there's how bad I am at French. But he used a lot of white space, a lot of black lines, and big color blocks. So the programming language is built on that. So these are all of your programming tools. These are all of your words, all of your everythings. And so you use these to control bit values, and then you can make programs with it. And what's cool is, like, that's Hello World in PA. And what's really cool, and where it gets to be amazing, is you can start to program languages with animated GIFs. So it's just a ridiculous, amazing programming language, but it's so pointless, right? Like, no one wants to try to read this code. If you went to any company and was like, "Hey, I'm gonna code in PA," once you explain to them what PA was, they would just have headaches immediately. So, yeah. KPM25 asks, "Can I start to build a web app and get it up and running in reasonable time with Java?" If you don't know any Java at all, it may take a while before you have a web app up and running. But there are web libraries, web frameworks for Java that will make that faster and easier. If you are a Treehouse student, we have courses over at least 2 of those. So you can check those out and see how to get going with web apps. If you don't know any Java at all, we do also have some Java basic stuff, which will teach you the basics of Java. Yeah, you can go from there. It's really hard to judge how long it takes to build something. It all depends on whether or not you know the language, right? Like, somebody who... I think Python's really fast to build things in. It's a quick language to pick up. But if you know nothing about Python, it's going to take, months, if not year or years, before you can actually get, like, a web app up and running. So, yeah. That's kind of just how that works. Akas, thanks for taking Python courses, and I'm glad that you were able to become a JavaScript developer through Treehouse. That's amazing. We love knowing that people have used our stuff to go on and make their lives better. So that's amazing. Congratulations. And you're welcome. All right, so any more questions? What's about Unity 3D? Unity 3D is a great library if you want to make 3D stuff and you want to use C#. I haven't played with it much. I've played with Unity a teeny tiny bit. I followed the tutorial and made a game over the Thanksgiving break a few weeks ago, and it was cool. It was neat. Unity seems nice. I don't know enough about it to say anything. Again, at Treehouse we do have some Unity courses, so if you want to learn more about Unity, you can come check out our stuff. And I think there's a new one coming out actually for VR, probably using Unity, about building a basketball game. So that one looks really cool. I know that Nick is really, really getting going with it. Alice Wood asks, "Can I learn ethical hacking on Treehouse?" No, we don't have anything on ethical hacking yet. Not that it's necessarily ethical hacking. I do want to start doing some courses on, like, cryptography and protection, like protecting your assets, protecting your communications. We don't have anything as far as, like, breaking stuff or digging into memory, things like that. As far as I know, I don't know of anything in that area. But if enough people asked for it, it's probably something we would start to investigate offering. Yeah, I don't know. But there is currently, right now, so, like, you'd have to go, like, today, or maybe there's another week, on Boing Boing, I think? Store.boing.net. I did see some sort of learning to program or something like that bundle. Maybe it was online courses? Let's find out. And they had something about, like, hacking. So, Like ethical hacking. Yeah, ethical hacking. There it is. $30, IT security and ethical hacking certification training. So that might be something to look into. That might be a thing to work with. So yeah, that's probably what I would check out first. Is that one. And then yeah, there's other resources. I'm sure people will post them in chat if they know of them. But yeah. And then sorry, not Alice. Chinchana asks, have you tried deep learning on Python yet? I've not done any machine learning with Python yet. Somebody's probably going to suggest that as a live coding topic one week. And then I'll have to do some. But I haven't played with it yet. I do want to. We've been talking about trying to get some machine learning, computer vision, data science courses going at Treehouse, but that's going to be a little while off. We have to find people that can teach them. We have to research the materials, and it may not even happen. But it's definitely an area that we're considering bringing in some content. So yeah, keep an eye out, and maybe we'll have some deep learning stuff. If you have some really good resources, send them to me, and I will read through them. And like I said, maybe we'll do a live stream on it one week. And Shaw asks, I want to learn C#. We have a couple of C# basics, like beginner C# courses on Treehouse. So you would just need to go, what is it? It's teamtreehouse.com/library. You would just have to go and find the C# courses that are on there. Excuse me. We do have several of them, and I know there's more coming. C#. Yeah. Oh, wow. They've put out a lot of content. So yeah, so there's a C# basics, C# objects. So you would just start, somewhere down here, and you just work your way through it. So we've got a lot of C# content on there. So, and your basic subscription will get you access to all of these except for this one here that's marked as Pro. So you will get a lot of stuff. And yeah, the video will be available. It'll be on YouTube within a couple of days. We'll have it live and in our live coding playlist. So you'll be able to watch it on YouTube, and it'll be available. It should be available right away once I end the stream on both Twitch and Beam. So if you use either of those, twitch.tv/team_treehouse and beam.pro/treehouse, if you use either of those, then you can find the videos probably a little faster. I'll put those links in here. And then beam.pro/treehouse. Both of those will have video on demand available, so you can just watch them. So, all right. It is 12:15, so I think I'm going to call it a day. I will see you all next week. I don't know what we're doing yet. We will code something. Maybe I'll go back to working on that roguelike, or maybe we'll just do something brand new. I've been wanting to play with movie.py for a while, so maybe we'll play with that. But thank you all for tuning in. Be sure to check out teamtreehouse.com if you're interested in learning to program. And yeah, thanks so much for watching. I'll see you all next week.